Hello, good afternoon, everybody. For those of you who I haven't met yet, I'm Julia Brun, and I lead developer advocacy initiatives here in the United States. It is such an honor to welcome all of you today for our very first Platform Leadership Forum at AU 2025. Thank you for choosing to spend your Monday with us. This forum is something new, and it's also something created because of you. Over the past year, we've heard your voices loud and clear. You wanted a dedicated space here in the United States to connect with your peers, share experiences, and learn more about how to create value and impact with Autodesk Platform Services. Today is about delivering on that request. It's about giving you space to learn from one another, to hear what's next from Autodesk. And it's also a space for us to listen to you and learn from this amazing, vibrant community. Before we get started, I do want to show you our Safe Harbor statement. Some of what you will hear today may refer to future direction. Today, I want you to see these discussions as a way to understand our vision, but please do not make any purchasing decisions based on any future-looking statements. With that, thank you again for being here and for trusting us to be a part of your journey. I hope you enjoy this forum.
I think AI is going to help us a lot.
It's not there to take their jobs, it's there to help them. I think that's the key challenge for the whole industry, not only us.
Generative design and AI, BIM modeling, creating multiple options in a short period of time.
Now we can spend time doing more important things and leaving the automation to a system that we can trust.
It is not an IT initiative any longer. It is a business initiative and it has to be driven from the top.
You need to stay ahead of the curve, you need to take risks.
See how fast the world is going. If you're not going with the stream, you're way behind.
I happen to be in this future, so
Please welcome Vice President of Developer Enablement, Ben Cochran.
good afternoon, everyone, and welcome to this Autodesk Platform Leadership Forum. Today, I want to start with a question. What would you build if you had no limitations? What if what was once too complex, too big, and too audacious simply wasn't anymore? And what if you could go back to having that childlike imagination? I have a story to share. I remember I was sitting with my teacher in 3rd grade. It was recess, and so I must have been in trouble. And I was telling her this story about an idea to add gravity onto the space shuttle. You see, I had just learned that being weightless in space is very hard on astronauts. And I, myself, I wanted to solve that problem. Now, my 3rd grade self had these limitless ideas. And that led to questions like, can't we put some sort of human centrifuge in the cargo bay? Okay. And I remember this moment. My teacher turned to me and said, if that was possible, don't you think they would have done it? I was crushed. And that feeling, it stayed with me. I tell you this story because over the years, we've all had these moments where our imagination is restricted. And as we grow in our careers, we make these mental models of what's possible and what's not. We lose that limitless, bold imagination. We sometimes call this wisdom. But when technology challenges, or when technology changes, conventional wisdom must be challenged. And now is the time when we need to go back to that childlike, limitless imagination. We need to go back to asking, what if? This is because right now, with agentic artificial intelligence, we can erase the boundaries of what we think is possible as we reimagine a new possible. And the pace of change is staggering, especially for software developers. Today, tools like Cursor and Claude Code partner with us as this machine helps us build something new. The AI agent writes code better and faster than I can, usually. It reasons through problems step by step, builds an execution plan, and drives it. With agentic AI, we can achieve outcomes that we once thought to be impossible. And so our job must shift. We need to reimagine the problems that we can solve and rethink the tools that we build. Year after year, we've said that change is coming. And together, we've worked towards more connected data and these connected workflows. Everything we've invested in, the data APIs, the data connectors, granular data, these are the foundations needed for agentic workflows. And APIs are the drivers of these agentic workflows. They give agents new power to execute against goals. Agents can now connect to multiple APIs and data connectors with a Model Context Protocol, or MCP. MCPs are APIs for agents, and this is a huge leap forward. MCP is the protocol for custom integrations. And with MCP, agents can orchestrate multiple tools and connected data sources to complete the outcomes that we need. Let's dive into an example. Victor is a platform for engineering automation. They asked, what if an agent could do the hard groundwork, all of the calculations needed for structural analysis? In this case, the agent finds the model in the electrical substation. It finds the electrical substation in the Autodesk Construction Cloud. It then creates the structural analysis needed for the design. It considers impacts of wind and wire load. And it simulates the stresses on the structure. The agent then takes the results and the simulations, along with the conditions, to make a recommendation. Once the engineer is able to approve the foundation design, the agent pushes the updates back into Autodesk Construction Cloud. This is a different way of working. It's in collaboration with the agents, where we set the conditions and the context, and the agent provides the specialized skills. I encourage you to explore this more with Victor. They're here this week at AU. Let's go back to my initial question for a moment. What would you make if you didn't have limitations? What would you make 100 times simpler, 100 times more productive? You know the spaces that need to be disrupted. You get to define the problems and build the tools for agents to solve these problems along with you. This is our business opportunity. And as you go after this opportunity, Autodesk is going to grow its API portfolio, giving you new endpoints and capabilities for agentic workflows. We're enhancing our industry data model APIs, building new capabilities, like the Sustainability Data API, and we're growing the data exchange connectors with the latest ones for Inventor, Rhino, and Tekla. We're investing in APS as a core business. This is for Autodesk and for you. Today, I want to share a preview of the new APS business model that is coming later this year. As we evolve APS, we will continue to elevate the platform experience today and expand your tool set to shape the agentic workflows of tomorrow. APS is going to have 2 tiers. In the future, a free tier for developers to experiment and build proofs of concept, and for customers with product subscriptions to access their product APIs. Building on this is the paid tier, with flexible options to pay for usage as you scale. With this evolution, APS is ready to support you as you reimagine what is possible for the future of design and make. You can learn more about this today at the APS business model session with Tula Kagar and Christian Hegedus. And the APS team is here to answer your questions throughout Autodesk University. Please reach out to them. Let me leave you with 3 ways to prepare for this agentic future. The first one, APS is evolving as your innovation partner. We see tremendous opportunity in building an agentic future together. And APS is going to continue to invest in more capabilities and richer insights for you to build agentic automations. Next, your business opportunities are changing. Agents are becoming very capable partners. I like to think of them as interns. They're smart, they're motivated, but they have zero context about the problems that need to be solved. It's our job to create that context and build the tools they need to get to that next level. That is our business opportunity. And third, our customers need new ways of working. A shift from working directly with the tools to supervising agents, from linear workflows to extremely fast experimentation. This makes making decisions in data silos to using data at scale. This shift leads us to be more productive and more creative in how we design and make a better world together. That youthful foolishness of my third grade self wasn't really foolishness. I'm going to call it brave ignorance of limitations. And my teacher wasn't wrong. The idea isn't practical when I was in third grade. As time goes on to be successful, we build conventional wisdom as we focus on what is practical. And we learn to limit ourselves. Yet, in this new time, I challenge you to be selectively foolish, to question what is practical. Our job is to know when limitations are no longer, and to seize the opportunities to make the impossible into the new possible. Today, at the Autodesk Platform Leadership Forum, and this entire week at AU, I encourage you to ask, what if? And now, please join me in welcoming Tonya Custis, Senior Director of AI Research at Autodesk. Tonya will share how a team of scientists at Autodesk is pushing the boundaries of what's possible with AI for our industries. Welcome, Tonya.
Thanks, Ben. Great to see everybody today. Agentic AI is already proving powerful at orchestrating existing workflows. But complementary to the possibilities we're seeing with agentic AI, there are also advances in AI science and the models themselves that can improve design and make workflows even further. And that's what I am here to talk to you about today. We've seen what public foundation models have done for text and image generation. What if we could do the same for 3D design? I have been doing AI research for 20 years at Thomson Reuters, Honeywell, eBay, and now Autodesk. But it's really only recently that anyone actually seems interested in what I've been working on this whole time. So here we are. I currently lead the Autodesk AI Lab, a group of AI research scientists working to advance the science of AI in ways that benefit Autodesk customers. It's our job to invent the AI capabilities that don't exist now, but that will improve your future workflows, to help you make what once seemed impossible into the new possible. Since I joined Autodesk in 2019, the AI Lab has published almost 100 scientific peer-reviewed papers, making us the world's leading lab in AI research for CAD geometry. My academic background is in music, which I only mention because we're in Nashville, linguistics, and computer science. Early in my career, my research centered on teaching computers human language. Since then, my research focus has shifted to geometry and thinking about how we might treat geometry itself as a language. What if we could teach computers to speak the language of 3D CAD geometry? Training a large language model to talk about CAD is possible and maybe even useful. But that's like me describing French grammar. It's not the same as speaking French fluently. Talking about 3D CAD geometry is not the same as generating or editing 3D CAD in a way that respects engineering constraints and the laws of physics. For AI, 3D generation isn't the end game. But just as you must speak a language to really understand it and use it effectively, an AI model must be able to generate geometry in order to understand it and reason about it. Absolutely no one wants a tool that generates a whole bridge or a building. But what if you had an AI collaborator who spoke fluent 3D CAD geometry and could propose design options, test constraints, and save you time? Most of the improvements we have seen in publicly available text and image AI models have been the result of just training them on more and more data. So it isn't surprising that today's most powerful generative AI text and image models were trained on the largest source of data available, the internet. Unfortunately, the specialized problems of Autodesk customers can't be solved with existing off-the-shelf software and general models trained on noisy, generic internet data. Manufacturing and AEC workflows require unique domain knowledge and a fluent understanding of 3D CAD geometry. Autodesk is taking an iterative approach to AI that's integrated across all the levels of software stack and our platform. We are delivering AI features today while also doing the AI research to prepare for what's coming. Our strategy is to deliver the AI functionalities and interactions our customers are becoming accustomed to from existing generative AI models, but that also support your specialized 3D workflows. The data that most existing generative AI models are trained on does not adequately encode or represent the domain expertise necessary to power AI for design and make workflows. And they primarily operate in one dimension, language, or two dimensions, images. 3D geometry is the next frontier ripe for an AI breakthrough, and one that is especially relevant to our customers. So that is where my team has been focusing our research for the past 5 years. And that is why we built Project Bernini, which we demoed last year at AU. Project Bernini was our first public-facing 3D generative model, but is definitely not our last. Andrew's general session tomorrow and other keynotes throughout AU will feature demonstrations of our new 3D generative AI models and capabilities. Project Bernini was trained on 10 million public 3D objects, the largest data set of its kind. This data set is licensed under various open source licenses that allow for research, but not for commercial use. As such, Project Bernini remains an experimental proof of concept only, and not a commercial offering. However, although it is only a research prototype, Project Bernini has taught us some very important lessons that we've been able to carry through to our other research on other 3D models that you'll hear about this week. First, scaling helps. Performance did, in fact, improve by adding more and more data. But second, public data isn't enough. Results were fine for rendering on screen, but we don't just want to generate pretty pictures. We want actual CAD designs that you can build and manufacture. There just isn't enough public 3D data to train 3D generative models that are comparable in performance to existing generative AI models for text and image. And most of the 3D data that is publicly available is not in 3D formats native to CAD or BIM software, nor is it at a high enough resolution for precise industry domains like manufacturing and AEC. We needed specialized data that encodes 3D geometry, engineering, and domain knowledge. And the third thing we learned is that we needed better AI science. The data-greedy methods used to train today's generative AI for text and images alone can't work for specialized 3D workflows. We needed smarter algorithms, better data representations, and methods that don't depend on internet-scale data. Even having assembled the largest known public 3D dataset, our Project Bernini dataset was still only 1% the size of GPT-4's training set. So we face both a data gap, but also a research opportunity. Of course, data is sensitive. Autodesk prioritizes customer needs and protects customer data through our trust principles for AI. These principles guide how we securely and ethically develop, train, and deploy our AI solutions. We have an industry-leading team of 200+ employees that focuses on ensuring security, privacy, compliance, trusted AI, and resilience across all of Autodesk products and processes. If you're interested in learning more, our Chief Trust Officer, Sebastian Goodwin, has a talk here later today. And as a research lab, we hold ourselves to the highest scientific rigor. We publish peer-reviewed papers, measure model performance with verifiable metrics, and enforce guardrails so that training data never appears in model outputs. Your data is yours, and we are here to partner with you so that you get the most benefit from that data as possible, to help you imagine a limitless future. Trust is embedded in our AI from data to science to delivery. AI at Autodesk isn't just something we do for you, it's something we do with you in order to push the boundaries of what is possible. If we can teach AI to speak the language of CAD fluently, we can transform how we design and make, turning design intent into 3D physical reality with AI as a trusted collaborator. Autodesk is investing in the platform, product experiences, and AI research to deliver meaningfully useful and trustworthy AI tools to our customers, both now and for the future of design and make. Next, I'm going to turn it over to one of our customers getting the most out of their data to realize the new possible, Jay Wratten.
Thank you, Tonya. I'm thrilled to be here. Honestly, I always thought if I was going to be on stage in Nashville, it'd be with a guitar around my neck and not these glowing shoes. It turns out I discovered another passion, using technology to make the world better, and it pays a lot better too. Today, I'll share how Autodesk Platform Services helps WSP change the way we work and why treating data as a long-term asset helps us shape resilient, thriving communities. Now, in central London, on the corner of Charterhouse and Farrington, a humble fruit cart run by J.J. Mack once served busy Londoners. It was exactly right for the city then, simple, immediate, human. But needs change. Cities change. On that same corner today stands the J.J. Mack building, one of London's smartest and most sustainable buildings. Achieving those outcomes is thanks to the design and construction data now living on through the building's operational digital twin. From day one, WSP treated data as part of the asset and not the paperwork around it. And in a 200,000 square foot building, there's a lot of data to be managed. We tagged 10,000 assets, connected 1,500 sensors, and managed data in a standard way. That data-first approach enabled 4D simulations that shaved 14 weeks off MEP installation during pandemic constraints. But data only matters when it changes behavior. So we made it usable for the people in the building. A tenant-facing app is the front door to the digital twin. It daylights all that data to every occupant, and it turns it into action. With it, people can adjust lighting and climate in real time, while the system streamlines access management, simplifies space booking, and nudges sustainable choices with clear feedback on air quality, energy use, and occupancy. When you put insight into people's hands, operations change. That's how this building uses 52% less energy than comparable offices, and it achieved the highest scoring BREEAM assessment in the UK. The fastest way to change a building is to change the choices inside it. It was a fruit cart then, an office building now. And when that site changes again, the same well-structured data that powered choices for occupants will speed decommissioning and repurposing for whatever comes next. It's a prime example of how WSP combines technical excellence and digital innovation to deliver lasting lifecycle value for clients, communities, and the environment. JJ Mack also signals a deeper shift in our industry. For most of my career, the AEC business model has priced time as a proxy for expertise. Clients and consultants alike have valued a contract by how long it takes to produce a set of construction documents. But buildings don't run on drawings. They run on data. And it's that data that enables value creation. We're moving from selling time to delivering outcomes. Our clients aren't just asking for plans or models anymore. They're asking for certainty, performance, and longevity. At WSP, our why is simple. We exist to shape communities to advance humanity. That means building infrastructure that's more resistant to shocks. It means accelerating the energy transition, making cities more livable, and helping our clients deliver long-term operational value, not just project handovers. To do that, we must connect what we design to how it performs. And we must treat data as an asset, not a deliverable. A thread running through the full life cycle, from concept to construction, to commissioning, and to continuous improvement. That's why JJ Mack isn't the end of the story. It's the beginning. It shows what's possible when we embed intelligence from day one. But to scale this, to move from one smart building to a platform of smart infrastructure, we need tools that support this mission. That's where Autodesk Platform Services comes in. Not as a product we're here to sell, but as a capability that helps us advance WSP's why. What does APS do for us? It brings models, live data, and workflows together, takes the friction out of repetitive steps, and puts practical tools in the hands of my teams so planning, maintenance, and performance can keep improving. With it, we can integrate asset and sensor data directly into the model so engineering intent lives on in operations. We can build internal tools that do the repeatable work for us, letting our experts spend time where their judgment counts. And we can develop digital twins that move from mirroring to improving, supporting planning, maintenance, and performance optimization. APS helps us do more of what we already do best. Use data to drive outcomes. It's not a departure from WSP's strategy, it's an enabler of it. Now let me give you one example where this matters next. For decades, our understanding of critical infrastructure centered on hospitals, police stations, water treatment plants, electrical substations, systems whose failure can paralyze communities. Now, advanced manufacturing is on that list, because supply chain fragility has become a risk to both businesses and their communities. Lead times are still long enough to rewrite a construction schedule twice. Boards are responding with a resilience strategy: shorter supply lines, tighter control, and more redundancy. And in many regions, that's showing up as reshoring. New capacity, and more often, new lines in existing sites. Which leads to the question we hear every week: how do we add capacity without downtime? How do we design for uptime, flexibility, and resilience? WSP is now applying the same thinking that enables the life cycle of a single commercial building to an industrial estate and environment. Imagine that you're Acme Manufacturing, makers of Nashville's favorite bourbon cocktail cherries. Yes, I know, cocktail cherries aren't exactly critical infrastructure, but let's stick with this example because it keeps me from having to dissect anybody's business strategy. Demand just spiked. You need to double capacity in 18 months by adding a new line to your aging facility without derailing production. You bring in WSP as your project manager and owner's engineer. Our first move isn't a drawing, it's reality capture. So everyone designs against truth, not assumptions. Side by side with your industrial engineers, we digitize the current line to see what flows and what jams. And we integrate that new line into the same digital model. From there, we simulate construction options in 4D and 5D, compare modular and prefab options to accelerate the schedule, and plan how the data will live on so the tags and asset information needed for an operational digital twin are baked in from day one. During construction, we connect supplier and contractor data flows. So handover isn't a dump, it's a continuum. The result? An Industry 4.0 ready facility with real-time visibility into throughput, downtime, and energy per batch, ready to scale when Nashville calls for that next round. With APS, we can integrate live performance data, automate asset documentation, and hand over an operational model that our clients can actually use. If the last decade was about digital delivery, the next is about digital continuity. The difference between finishing a project and starting a product. Imagine walking into a facility where the model knows the day's production plan, the sensors know the weather and the load, and the system nudges the team, start line 2 5 minutes early, shift cooling set point by 1 degree, divert maintenance to pump B. No heroics, just 1,000 tiny decisions guided by data, stacking up to resilience that you can feel in the output and in the margin. At WSP, we're not building projects anymore. We're building platforms. So what does that mean for us? Together. We're weaving data through everything we touch, from buildings to factories, from infrastructure to environments. Autodesk Platform Services helps us do that, but it's not about the technology alone. It's about that shared vision, that engineering data shouldn't sit in PDFs, the digital version of binders in a basement. It should power real-world performance. That's the opportunity in front of us. Not to digitize what we've always done, but to transform what's possible when domain expertise meets connected data and when platforms deliver outcomes. Let's co-create that vision together. If data is the language, let's make performance the conversation. Thank you. Still no guitar, but I've got a great following act. Autodesk's Chief Sustainability Officer will show us how platform software, connected data, and human ingenuity lets us push past the old limits of traditional workflows and deliver the sustainable future our customers and the planet demand. Please welcome Joe Speicher.
Good afternoon, everyone. It is great to be here in Nashville, a city known for its creativity, reinvention, and yes, some very questionable karaoke choices. Jay could bring up his guitar. I'm a fan of Dolly Parton. I could get a blonde wig. Jay, you can bring your guitar. We could do a rousing rendition of Jolene for this crew. As Ben encouraged us, that might not be selectively foolish. It might just be foolish. We'll leave that as it is. But the point is, the city's about reinvention. And that's exactly what we're here to talk about today. So before I jump in, I want to be clear from the start. The transition to a low carbon future is not slowing down. It's actually accelerating, and it's inevitable. And now, for the first time, we have both the tools and the line of sight to scale it with confidence, to drive it further and faster than ever before. As Jay showed us with the JJ Mack building, one of the most sustainable in London, how connected data can drive better outcomes. And Ben highlighted the limitless possibilities that agentic AI can deliver. So the question for all of us in this room is, what do we do with this? As inspiring as these examples and provocations are, they are just the beginning. It is up to all of us in this room, the developers, the technologists, the builders of this platform, to deliver the future that we need to see. So let's first talk about why. I'm going to start with the facts. Climate change does not stop at borders or ballots. Last year was the hottest year on record once again. We passed the 1.5 degrees Celsius threshold as outlined by the Paris Climate Agreement for the first time. And the industries that we serve, that Autodesk serves, architecture, engineering, construction, operations, and manufacturing, are associated with roughly 58% of total global greenhouse gas emissions every single year. This makes it not a planetary imperative, but a strategic business priority. Why? Because the low carbon transition is happening, and it is the opportunity of our generation, not just to reduce risk to the planet, but to realize growth for all of our businesses. And let me convince you why. Consider this. Last year alone, the world invested over $2 trillion in this low carbon transition. 42 countries around the globe, including the US and most of the member states of the EU, have put peak carbon emissions in their rear view mirror. So when we are talking about sustainability, we're not talking about future hypotheticals. We are talking about market momentum that is already reshaping the industries we serve, and we now have the tools to accelerate it. Now, there's a tension here that's hard to ignore: the rise of AI. It is extraordinary, and it is extraordinarily energy intensive. If left unchecked, its growth could derail all of our climate goals as demand for compute power skyrockets. But here's the great news. It doesn't have to. If we drive AI's promise towards efficiency and sustainability, if we build the infrastructure of AI to be low carbon, and we direct AI to optimize energy and materials across entire systems, then AI becomes not a headwind, but a tailwind. The difference is how we design, how we deploy, and how we build on the platform together. And that is why the role of technology is so critical to this future. So we do this at Autodesk by connecting people, processes, and data. And our platform helps teams build and operate with sustainability at the core. Connected data, as you heard from Jay, is the lever. And connected here is the key word. In order to solve for the optimization of outcomes, like the JJ Mack building did, you need data flowing across silos. This requires collaboration. And when we connect data across every phase, radical collaboration stops being optional and starts delivering the outcomes that we could not achieve alone. It lets us model, simulate, and optimize entire systems before a shovel hits the ground or a machine starts on the factory floor. And when that data flows seamlessly across the value chain, from architects to contractors, from designers to manufacturers, and from operators to owners, it cuts waste, it boosts efficiency, and it sharpens our collective decision making. That's how we move from small, siloed, incremental gains to collective, system-wide impacts. And now, as you've heard from Ben, we are at the threshold of something even bigger. Agentic AI changes the equation. This is not just about automating tasks. It's about machines that can reason across entire systems, continuously optimizing as new data flows in and breaking down silos. Think about the talk you just heard from Ben about the limitless potential of agentic AI. Pair that with the story of the J.J. Mack building, where connected data drove better outcomes. And let's explore how some of our other customers are already using Autodesk Platform to drive that change. First, let's go to Toledo, Ohio, to take a look at what Arcadis has done. The city was faced with a harmful accumulation of algae, and city leaders quickly realized they had to modernize and expand the city's water plant. It's worth noting here that this occurred during the COVID-19 pandemic. We all experienced the unprecedented challenges of restrictions on crew sizes and disrupted supply chains. The stakes in this case couldn't have been higher. We know what happens when this goes wrong. Clean, potable water for hundreds of thousands of people. So, using Autodesk's cloud-based BIM technology, Arcadis was able to achieve what traditional approaches could not. They saved more than 1,000 design hours, they reduced coordination delays, but most importantly, they delivered 2 new water basins on schedule with resilience and sustainability built into the deliverable. This wasn't just about working faster, it was about impact for both people and planet. These digital workflows kept teams aligned, accelerated delivery, and helped deliver infrastructure that was stronger, smarter, and more sustainable. Now, let's go to Oakland, California. It's a little bit closer to home for me. Turner Construction was faced with the challenge of building a central utility plant at Oakland San Francisco Bay International Airport. At 8,300 square feet, it was packed with complex electrical, mechanical, and HVAC systems, all of which were critical to ensuring the airport ran smoothly. It was a challenging build. It required significant coordination across many subcontractors. To tackle this, they created a detailed 3D model and leveraged cloud-based BIM throughout the construction process, giving the team real-time access to the live model, whether they were in the office or on the job site. And the results were immediate. Better coordination, faster decision-making, and fewer misunderstandings. The project stayed on time and within budget, which is no mean feat. For Turner, leveraging technology wasn't just about visuals and collaboration. It became the engine that led to a more efficient, synchronized, and sustainable outcome. As inspiring as these examples are, they're just the starting line. Most projects today do not have that level of integration or continuity, as Jay mentioned. Data does not flow seamlessly across the lifecycle of every project. Continuous optimization is not yet standard. That is the gap that we need to close. And agentic AI, powered by connected MCP servers and API-driven ecosystems, gives us the chance to eliminate complexity, to break down silos, and to make sustainability the default. And this is where you all come in. This is the promise of our platform. So Autodesk will provide the rails, the platform, the infrastructure, the data flow, but as developers, you're not just passengers. You are the ones writing the code, connecting the ecosystems, and ultimately building the engines that will move entire industries forward. Applications that make sustainability data visible and actionable, streamlining complex trade-offs, optimizing for carbon, cost, and performance, all doing so simultaneously. Because as inspiring as the J.J. Mack building is, it is still the exception to the rule. And we need to scale this. Real transformation requires scale. And scale requires radical collaboration across silos, across personas, and across phases of project delivery. So Autodesk is committed to catalyzing those connections. But the real power comes from what all of you can build on top of it. What if, to Ben's point, generative design extensions that optimize for cost, carbon, and resilience all at once, digital twins that prove performance with live data, data connectors that surface carbon impacts inside everyday simple decisions. This is not our roadmap. This is your canvas. Every integration, every API call, every agent you deploy is not just code, it is a climate outcome. Now, I realize there's some irony here. We're asking you to save the world with code. We've heard this before. It's at the same time that agentic AI is supposedly meant to automate half of what you do. I'm here to tell you that the machines can't replace you because you're the decision maker, and they can't figure out how to sit through a painful requirements meeting. More importantly, you decide what to build. You decide what to prompt. We don't need more prompts for AI jingles or Seinfeld scripts. We need prompts and agents that tackle energy use and materials efficiency and ultimately climate impacts, problems that actually matter. These are smarter decisions made earlier, carried through from concept all the way through operations and decommissioning. That is the role of connected platforms and agentic AI in helping all of us to decarbonize the built environment and the manufacturing sectors. That's the opportunity in front of all of us. The future is innovation plus radical collaboration. And if we get this right, it won't just be buildings like the JJ Mack one in London. It will be every building, every factory, every product designed and delivered to perform better, both for your business and for the planet. So we are currently at a pivotal moment. The choices that we make, what we build for, what we optimize for, this will shape the future for generations to come. And we know that we can't do this alone. We need, again, all of us in this room, the developers, partners, technologists, to deliver the APIs, data connectors, and agentic workflows that bring this platform to life, to create value for your customers and value for the planet. Because climate change isn't bound by geography or ideology. It is a global challenge, and it demands a global, coordinated response. What if we build the digital tools that drive a lower carbon, more resilient future together? What if we empower every designer, engineer, builder, manufacturer to make better choices, and we do so together? What if we ensure that what is designed is what is built, and what is built performs as it should, and we do so together? Let's keep building, let's keep connecting, and let's keep making progress together. Thank you.